You're watching In Technology, a video cast where you can get smarter about cybersecurity, sustainability, and technology.
Hi, I'm Camille Morhart, host of In Technology podcast. Thanks for joining me as we look back at some listener favorite topics from this year. For this episode, we're going to focus on cybersecurity, and our listeners were curious this year about several facets in cybersecurity, from firmware attacks to deep fakes. Our conversation back in January with Jorge Mijny drew a lot of interest. Jorge is the co-founder of Chameleon, which is a hardware security startup. Former co-host Tom Garrison and I invited him onto the podcast to talk about firmware attacks. And Jorge told us that in the last 3 to 4 years, there's been a 5-fold increase.
It's very difficult to, one, to detect it, but two, it doesn't disappear. It's persistent. You turn off your computer, you turn it on, and it will load the same malicious firmware again. And if you are a smart attacker, you will disable the update so you can't change it. So then physically you need to go and remove the flash or do something physically. So it's very expensive. It's not just having an antivirus and, okay, let's update the antivirus database. It doesn't work the way. And if you have it in a server, in a data center with 100,000 servers, and you need to find that server and physically open it up and do something, that is very, very expensive. The challenge is that the firmware is loaded before the operating system exists. So all the tools, all the security tools that we use, let's call, for example, an antivirus, it's loaded after the operating system. It's an application, or kind of an application. It happened after the firmware is loaded. So if the firmware is malicious, it's very difficult for an application to understand that that firmware is malicious. So that's why we need the root of trust. We need to stop that when it's happening. And when it's happening, there is no software. So it has to be done in hardware. We need to have a device in the system that is the root of trust, that is in charge of verifying that that is correct, that is authentic.
How do companies protect themselves against these attacks?
Actually, the protection starts in the supply chain. And there are things that we do while the root of trust is added into a motherboard, a server motherboard, to bind it to the memory. So be able to detect if someone changes things. So we try to connect everything in a way that we can detect any changes that happen even before the system is turned on. We have a manifest, we have a database, we know what it should be there. We need to verify that what we have is there. And eventually we also can interrogate peripherals that are on the system and verify that those peripherals that boot by themselves are also original and authentic.
Again, that's Jorge Mijny, co-founder of the hardware security startup Chameleon. Our next listener favorite also touched on root of trust, but in this case, trust that your data is secure when you're using it in the cloud. This is known as confidential computing, and we had the perfect expert, Mark Russinovich, technical fellow as well as chief technology officer at Microsoft Azure, to explain.
So confidential computing is the use of hardware to create enclaves or computational containers where code and data can be protected while it's in use. And that's in contrast to the kinds of protections we've had up to now, which are protecting data at rest with encryption at rest, protecting it on the wire with, for example, TLS. And there's another important aspect to confidential computing's definition, which is not just protecting that code and data from external access and tampering, but also being able to attest to what's inside of the container. So it understands exactly what it's talking to, and then therefore can release secrets to it, for example, to allow it to decrypt data it wants the container to process.
Mark Russinovich spoke with me and guest co-host Anil Rao, an Intel vice president and general manager, about some of the leaps made this year toward confidential computing in the cloud.
We are on the verge of really removing the last kind of caveats on confidential computing to make it ubiquitous. And so Microsoft's goal with support of Intel is to aim for a confidential computing cloud, a confidential cloud. And that means that our PaaS services will all be confidential and have that extra layer of defense in depth, that customers can protect their own workloads with very high degrees of policy controls and assurances that their data is being protected end to end, regardless of what kind of computations they're going to be performing, the AI, ML, data analytics, or their own data processing on them. We've got confidential virtual machines that allow us to, for example, have confidential virtual desktop in Azure or confidential Kubernetes nodes in Azure. And we're moving to flesh out the rest of that environment to have confidential containers, confidential PaaS services. And in fact, we've got confidential Databricks we've announced in partnership with Databricks. So this foundation pieces are landing into place. The barriers to adopting confidential computing are falling by the way. We've got confidential GPUs now with working with you. We've got TDX.io. I know that's not the name of TDX Connect. TDX Connect, the new name for it, to allow complete protection between a CPU and an accelerated device like a GPU. So these things are landing in place. We're about to enter the phase of, hey, now the reason will be why confidential computing, or why can't I do confidential computing? It would be why am I not doing confidential computing?
One of the things that we know is that with AI getting so pervasive and data kind of like flowing in so many different areas, we see that training is going to be done most often in a cloud kind of like an environment. Not to say that inference is not happening there, but then the models get distributed, data gets distributed, and inference may happen at the edge, or even like incremental training may happen in something like an edge environment. So given this to be the holistic scenario, what are your thoughts on a SaaS service like Intel Trust Authority, and what role does it play in order to provide assurance of security for those AI models that may float anywhere from cloud to edge to potentially even devices?
Yeah, well, so a key part of confidential computing, like I mentioned, is attestation and the verification of the claims that come from the hardware about what's inside of in the enclave. What's an extra degree of complexity for somebody that is saying, can I trust this thing to release data to it? Or do I trust its answers coming back? And basically, do I trust that it's being protected by confidential computing hardware, like TDX, for example, or a confidential GPU? That attestation report carries a lot of information that's complex to reason over and come up with a valid, yes, this is something I trust. Not only that, but there could be configuration that is part of the attestation report that needs to also be looked at. And then typically there's some policy of, I'll trust things that are these versions and that have this configuration, and I won't trust anything else. And so for something that is going to establish trust in the enclave or the GPU, it actually simplifies things tremendously if you can offload the complexity of that policy evaluation and verifying that the hardware claims are actually valid and signed by Intel, for example, to an attestation service that does that complex processing and reasoning and policy evaluation. And so that's exactly what Intel Trust Authority is a system that an attestation service at the core of it, which takes those claims, the relying party, somebody that wants to see if I can trust something, can rely on the trust authority to say, yep, this meets the policies that you've got, and it is valid confidential computing hardware that is protecting this piece of code, so you can trust releasing secrets to it.
That was Mark Russinovich, Technical Fellow and CTO at Microsoft Azure. Our wide-ranging conversation with Mark also discussed data sovereignty, confidential AI, and much more. To listen to the entire episode, which I recommend, click on the link in the show notes. In the last of our listener favorites on cybersecurity, we move away from data protection to identity protection. With the advent of more and more powerful AI tools, there have been more concerns about fake images, fake videos, commonly known as deepfakes. They look and sound authentic, but they aren't. In January, I spoke with Ilke Demir, who's a senior staff researcher at Intel Labs, about advances in detecting deepfakes. Ilke is actually one of the creators of a tool designed to pick out the real from the fake in video, now called Deepfake Detection as a Service using FakeCatcher. We reference it simply as FakeCatcher during this conversation.
researchers first introduced methods that are looking at artifacts of fakery in a blind way. So if the idea is if we train a powerful network on enough data of fakes and reals, it will at some point learn to distinguish between fakes and reals because there are like boundary artifacts, symmetry artifacts, etc. Well, that is a way, of course, and it is working for some cases, but mostly those are very open to adversarial attacks. Those are very open to have the tendency to overfit to the data sets that they are generated on. And they are not really open for domain transfer or open for like generalization capability of those detectors. We twisted that question. Instead of asking what is the artifacts of fakery or what is wrong with the video, we asked what is unique in humans. Are there any authenticity signatures in humans as watermark of being human? Following that kind of thought, we have many different detectors that are looking at authenticity signatures. FakeCatcher is our first one. We are looking at your heart rate, basically. So when your heart pumps blood, it goes to your veins, and the veins change color based on the oxygen they are containing. That color change is, of course, not visible to us humans. Like, we don't look at the video and say, oh yeah, she's changing color. We don't do that. But computationally, it is visible. And those are called photophotoplethysmography, PPG signals. So we take those PPG signals from many places on your face, create PPG maps from their temporal, spectral, and spatial correlations, and then train a neural network on top of PPG maps to enable deepfake detection. Now, that FakeCatcher is just one of them. We also have other approaches like eye gaze-based detection. So normally humans, when we look at a point, they converge on that point, right? But for deepfakes, it's like googly eyes. Of course, not as visible, but they are less correlated, etc. So we collect all the like size, area, color, gaze direction, 3D gaze points, all those information from eyes and gazes, and train a deep neural network on those gaze signatures to detect whether they are fake or not.
So will there be ultimately then some kind of movement toward establishing provenance when videos are made? Or by provenance, I mean the origin can be proved somehow or attested somehow as the true source?
Exactly. You are just on that point. I was about to say that. So, of course, this is like the evil future from generation standpoint. But from like other research, of course, there's detection as the short term. But for long term, there's media provenance research that is going on very in a collective way. And media provenance is knowing how a piece of media was created, who created it, why it was created. Was it created with consent? Then throughout the life of media, was there any edits? Who made the edits? Was edits like allowed as a, like all of the life of media and what happened to it will be stored in that provenance information. And because of that provenance information, we will be able to believe what we see, saying that, okay, like we know the source, we know the edit history, etc. So this is a legit piece of media, which is original or fake, because there are so many creative people like visual artists, like studios, and those are like, those have been creating synthetic media and synthetic data like through their lives. So we want to also enable that.
Ilke Demir, senior staff researcher at Intel Labs, talking with me back in January about detecting deep fakes. If you want to hear more of the episodes we highlighted today, you'll find the links to each of them in the show notes for the episode. And as always, you can find In Technology podcasts on your favorite listening platform or at our website, intechnology.intel.com. In a few weeks, we'll have the last of our 2023 listener favorites episodes for you, and that one will go in depth on AI topics from this year. Think generative AI, synthetic data, LLMs, and more. Don't miss it.
Never miss an episode of In Technology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.